Hi, so in this video I'm just going to take you over some integral calculus. Integral calculus is the same as anti-differentiation, the opposite of differentiation. So we're doing quite a number of questions. These are the questions that we are solving. Okay, so basic integration, integration of trig functions, application of integration. You can see different forms of integration by partial fractions, and also its application in determining the area. All these questions are answered in this video. So let's get started. So I'll give you an example of a very basic differentiation. If I was to tell you to differentiate, you'd multiply these 3 and 4 to find what would normally call dy dx. That would be 12, and then you would reduce the power of x by 1, it would become 3. Now integration is the opposite of that. So you know that, how do we reverse the 12x to the power 3 back to that? So we'll do the opposite. So we'll add the 1 to the power and then divide by the result. So that would be 12x to the power 4 divided by 4. Then you add a constant c. The reason why we add a constant c is maybe we had a 1 there, right? So that would basically give us a 0 when you differentiate a constant. So this in return reduces to 3x to the power 4. That is exactly what integration is all about. So we'll start with the basic one there, that we have 12x to the power 3 plus 5x squared and then minus a 6. The question is, can we evaluate each of the following indefinite integrals? Okay, so very basic, right? So what do? We need to add the 1 to the powers. That's the first step. So that will be 12x 3 plus 1 plus 5x 2 plus 1 minus the constant 6. Now when you see a constant, you will have to introduce an imaginary variable which is raised to the power 0, because you know that any variable, any number to the power 0 is a 1. So it would imply on the next stage it would just be to the power 1 when you add the 1 to the 0. Divide by the results. 3 plus 1 is 4, 2 plus 1 is 3, and that is just the 1 plus a constant c. Then that would basically result in 2. So 12 divided by 4, that would be 3 x to the power 4 plus 5 over 3. X will now be the power what? 3 minus 6 x plus c. That is our first integral result. Okay, simple and straightforward. Now we can move to b. For b, it's becoming more interesting in that we're now introducing the trig, right? So 4x plus secant squared of x and then dx. We need to integrate this. So before we go any further, I need to remind you of some things that you need to know when it comes to the derivatives and the integrals of trig functions. So starting from the basic ones, you and I know that the derivative of sine of x, when you are trying to differentiate sine of x, it's what? It's cosine of x. Okay. You and I also know that if we're trying to differentiate the cosine of x, so that would mean, like, say, the derivative of that. Let me just do the same. So the derivative of cosine of x is what? It's the opposite, negative sine of x. Okay. What happens if I take you to the next step, to the other interesting ones? What's the derivative of tan of x? What's the derivative of tan of x? So derivative of tan of x is secant squared of x. Okay, make sure you're creating a mind map as I write these. So these are the first 3 basic trig functions, right? And these are their derivatives. Now let's go to the other 3 that we know. These are obviously secant of x, cosecant of x, and cotangent of x. So these are the only ones that we need to know now. Okay, so the derivative of secant of x is a product, that is secant of x tangent of x. Okay, that is for secant. Then for cosecant, it's negative cosecant of x, so negative cosecant of x cotangent of x. So I think one of the mind maps that I'm creating here is the fact that if I look at secant and cosecant, they all start with themselves in their differentiation, and then they're a product. Okay, then for cotangent, on the other hand, it is negative cosecant squared of x. Okay, now when it comes to integration, integration is the opposite. So if I say the integral of cosine of x, it should give you that. So if you know one, you should be able to identify the other, right? Okay, so away from that, now let me take you back. So we need to integrate 4x and then also secant squared of x. So secant squared of x, we saw that the derivative of tangent of x was what? So derivative of tangent of x gave us secant squared of x. So therefore, the integral of secant squared of x should be able to give us what? Tan squared of x. Not tan squared. The integral of tan, the derivative of tan rather, is what? Secant squared of x. So therefore, the integral of secant squared of x is tan of x. Okay, so we'll start. Derivative of 4x, the power is supposed to increase by 1 on the x, so it becomes 1 plus 1 divided by the result, which is 2. Now the integral of secant square of x is the opposite of differentiating, right? So what can give a secant square of x is the derivative of tan, so therefore that is tan of x, okay, plus a constant c. So just familiarize yourself with these, and then you'll be able to do the reversals. We'll go to c. C is the derivative of secant of 3x, and then tan 3x. So already when you think of the product of two trig functions, what comes to your mind? Let me take you back a little bit. The integral of secant of x and the integral of what? So actually we were talking about the derivatives there, if you remember. So the derivative of secant of x and then also the derivative of cosecant of x. So I said you started, the mind map we were creating together was the fact that these start with themselves, right? So that would be secant of x. Okay, that's the first part. The other one will start with itself as well, except it also starts with a negative. Then the first one will have tan, then the other one will have what? 1 over tan, which would of course would be cotangent, right? So derivative of cosecant of x is minus cosecant of x, and then cotangent of x. Okay, now can you see now which one is very close to what we have? It's clearly the first one, right? So there is dx at the end there. Okay, so now we can break this down. So we want to do away with the dx that is at the end, if you wish, but at the end of the day we just end up with a similar answer. So these are the same. We can wish to call them u, so that we have the integral of secant of u and then tan u. Then for the dx, we know that our u in this case, we've made it to be equivalent to the 3x for us to be able to substitute. And then if we try to differentiate du, will give us derivative of 3x is 3. This is in respect to x, right? So du dx. Now you decide to make du or dx a subject of the formula. If you cross and multiply, you're going to have 3 dx is equal to du, and then divide both sides by 3. You end up with, where there's dx would be equivalent to du over 3. You can pull out a 3. Since it's on the denominator, this can become 1 over 3. Okay, so that in the brackets you remain with secant of u and then tan of u in respect to u, which clearly identifies with our interest, right? And you know what our interest is. This tells us that the integral of secant of u tan u, just what's starting there, is what? Is secant of the u. Okay, that is the derivative, or that is the integral rather, of that. So that is plus c. Now, which you know that the u was just 3x plus c. That's how you differentiate c. Now we can move over to d. D is as simple as the sine of 2x minus 1. These are the first ones I was talking about. These are the basic trig functions. The derivative of sine of x is as simple as cosine of x, right? For the opposite, if I say derivative of cosine of x, it's the opposite except there is a negative sine of x. So now when we say the derivative, or when we say the integral rather, it's like this. Then the integral of those ones will give you these ones. So the integral of sine is cosine, but it becomes a negative. Okay, how? Check this. The derivative gives you positive, so the integral of negative sine gives us positive cosine. So the integral of positive sine is negative cosine there. Now do this again, because of what we have in the brackets, we can have it be equivalent to a u, right? So let our u be equal to 2x minus 1. We usually do this even when you're differentiating, when it comes to dealing with trig functions. So our du becomes derivative of 2x minus 1, that would be 2. The constant will just give us a 0. So this is du dx. You want to make your dx a subject of the formula, it becomes du over 2 is equal to dx, right? I don't have to teach you all, that's basic mathematics there. You're just making dx the subject of the formula. So you now have, as you integrate that, you now have sine, what's in the brackets is now become u, dx is du over 2. You can pull out again the fraction, 1 over 2, then integral of sine u du remains, which is now the basic integral that we know. So the integral of sine of u is going to be the negative of cosine of u plus constant c at the end, which if we distribute the half, it will be negative 1 over 2 cosine. Now our u, we know it was 2x minus 1 plus a constant c. That is our answer for D. Apply the same concept, similar concept, to answer E. So E is the integral of cosine of 7x plus 1 dx. Okay, how do we answer this? This is a very basic and simple question. Similarly, we know that the derivative of sine is what? Is cosine of x. So the integral of cosine of x is sine of x, so we know it is sine of x. If I never had time, I would just rush this. How would I answer it? Okay, the first step, as usual, let what is in the brackets be equal to u. It becomes 7x plus 1, so du becomes 7 du dx. So therefore your dx becomes du over 7, and then the integral of cosine, what's in the brackets has become u, the dx. So this is now what I'm saying. If I had no time, I would just maintain what is in the brackets, but let me just do everything for you in the same way. So this becomes cosine of u. For our dx, it becomes du over 7. You pull out the 7, which is 1 over 7, cosine of our u, which is 7x plus 1. No, we need to integrate first of all before we get to this point. So 1 over 7 integral of cosine of u, and then remaining with a du there. So at that point, it's very basic and straightforward. So the integral of cosine is just sine. We're just reversing the derivative. So that is sine of u plus constant c. So 1 over 7 sine 7x plus 1 plus constant c. That is the integral. Okay. Now we have one more. We have got one more to answer. Okay. So that is the integral of e to the power 4x plus cosine 7x minus 2. So we can distribute the integral to all of them, right? So how do we integrate this? So when it comes to the exponential, if you say whatever you see, when it comes to differentiation, if you're differentiating that, then you are supposed to just multiply by the derivative of the power. In that case, it would be 4e to the power 4x. But then for integration, it's the opposite. It's the opposite. So it's just going to be as simple as, we'll maintain it for now so that we focus on the other part which requires some steps. So the integral of cosine 7x minus 2, it will just be done in the similar manner as that one. So I can even predict the answer. So the integral of this is going to be what? So differentiate what is in the brackets. If you differentiate what is in the brackets, you're going to get your du dx, if you decide to call that u. So that would probably give you a 7, right? When you differentiate that, what is in the brackets. Then that 7 is just going to end up 1 over 7 there. 1 over 7, and then the brackets will maintain the integral of cosine 7x minus 2. Okay. So at this point now, when it comes to the integral of exponential, you just differentiate the power and divide by the result, plus 1 over 7. Now cosine of this, the integral of cosine is just sine. So that will be sine 7x minus 2, and then plus a c at the end right there. So therefore what we end up with is e to the power 4x over 4 plus 1 over 7 sine 7x minus 2 plus a constant c. Okay, so nothing complicated, nothing difficult, or just something very simple, right? Which, if you want, you can even write this to just be over 7 like that, plus c. So that's how you are supposed to handle question 1. Question 2 says find the equation of a curve y that passes at 2, 3 given that dy dx is equal to that. So this is all just based on the integration. We are told our dy dx is equal to 3x squared minus 4x. Then we are told we need to find the equation of a curve y. So we need to find y. Then we are told this curve y passes through a point 2, 3. So dy dx implies that you are differentiated to the original curve y in respect to x. So if we are to find y, we need to integrate dy dx. So in short, y is going to be the integral of the 3x squared minus the 4x. Okay, so therefore let's integrate that. So integration is going to involve us adding a 1 to the power, so the 2 will become plus 1, the x to the power 1 will become 2. So this is going to be 3 divided by the 3 minus 4x will become the power 2 now divided by the 2 plus a constant c. Our y therefore becomes x to the power 3 minus 2 x squared plus c right there. And therefore our y is equal to x to the power 3 minus 2x squared plus c after the integration. Now at this point our goal is to find a constant c. So that is why that point comes in. So we can just substitute our y value is 3 and then our x is 2. So 2 to the power 3 minus 2 squared plus c. So 3 is equal to, this is 8, that should also be 8 plus c. So 3 is equal to just c. So our c becomes 3. So therefore our equation, if we go back to substitute our y becomes x to the power 3 minus 2x squared plus 3 as our constant, right? That's how you handle question 2. So I want you now to pause the video and apply the same concept to answer question 3. Find the equation of a curve y that passes at that point given that the dy dx is that. Okay, so I want to see the answer in the comment section below. I want you to comment in the comment section. We rarely comment on the video, so I want you to comment your answer and then we'll see what your friends have to say. Okay, let's move. Hi, so I just wanted to let you know that all these questions, all the way from 1 up to question 11, are all answered. Okay, from the area concepts, different kind of integrals, partial fractions, by parts, U substitution, trigonometric functions are all handled in this video. And of course, if you want to learn the other concepts of calculus, they're available on our site. The link is in the description below. You'll be able to learn everything from scratch and of course have the direct solutions to this tutorial sheet in full. Alright, so we can now start. Yeah, the more you get familiar with identities, the more it will be easy for you to answer these. So practice. Okay, so the first one, the integral of sine squared of x cosine squared of x. Okay, so how do we handle this? If you look at it, it's actually complicated for you to just integrate that directly. Okay, it's always simple and straightforward if you're trying to integrate something that is like sine squared of x plus cosine of x. Oh, I mean sine of x. This is at least the same variable, meaning that you can actually distribute the integral to each one of them. Now when you've got something like this, a product of two different things, it becomes a different issue. Okay, so let's try to break this down. Now we've got a common square there. I'll use a bit of some unrealistic mathematics. Okay, so sine of x, cosine of x, since this is a product, we can pull out the square. Okay, now does anything look familiar to any of the identities that you know? Okay, I don't know about you, but to me something looks familiar there. This part looks very familiar. I know that from the double angle identities, sine 2x is basically equivalent to 2 sine of x cosine of x. Okay, so we know how we expand that. Okay, and again, I'll invite you, if you are new to that, use the link in the description below to learn trigonometry. Okay, so in this case, what we have on the other side is sine of x cosine of x, which is like half, right? That is 2, this is 1. So therefore, we can just introduce the similarity there, because if you check, here we've got 1, there we've got 2. Now here you've got 1, so here you should have half. So half sine of 2x should give us that. Okay, so therefore what we have there is half. Okay, so that would be this 1 over 2 sine of 2x squared. Okay, now we can basically multiply this by itself. Half times half, since it is squared, is going to give us 1 over 4. That will become sine squared. Of course, the 2x will just remain. Okay, we've reached that point now. So 1 over 4 sine squared of the double angle, which makes more sense if you put in brackets. Okay, so don't forget the integral is still dropping because we haven't yet integrated. Okay, now at this point, are we able to integrate? So whenever you see the square, we don't want to complicate things. So whenever you see the square, you're supposed to use an identity as well. I need to mention that. And if you remember, I mentioned wherever you saw this was probably under the what we're calling the half angles, right? Half angle formulas. I told you to say if you had to have sine square of 2x, right? On the other side, you're going to have the 1 minus cosine. Okay. In fact, let me even make it more the way it was. Sine squared of theta. Okay. Sine squared of theta is equal to 1 minus cosine of 2 theta over 2. Now, if you look at what we have sine squared of 2x. Sine squared of 2x. So if we try to apply that same identity there, sine squared of 2x, what does it become? So it becomes 1 minus. Now if you check the relationship between the angles, that is twice, theta twice. So that's going to be from 2x is going to be 4x. So cosine 4x. Okay. Then on the bottom, the 2 is independent of all this. Okay. So that's what we have. And it's better to have it in this form than to have it in this form. So we'll just substitute. So we'll have the integral of 1 over 4. The sine squared would be 1 minus cosine 4x over 2, right? Now on the next step, we can decide to pull out, of course, the 1 over 4. Okay, can decide to pull out the 1 over 4. 1 over 4, remain with 1 minus cosine of 4x over 2. Okay, now at this point you can decide to pull out again the half which is on the bottom. In other terms, we should have just multiplied this 2 times that 4 so that we just have 1 over 8, right? So you can just remove it so that this becomes 1 over 8 there. Okay, now what you're seeing there is 1 minus cosine 4x, which looks at least very, very easy for you to navigate through when it comes to integration. Okay, so let's try to integrate them now one by one. So I want you to know that this has been simplified to 1 over 8, the integral of 1 minus cosine of 4x. Okay, now step by step, what is the integral of 1? Okay, what is the integral of 1? I know that is going to confuse you, but then what will remind you is the fact that we have the x at the end. So we're trying to integrate in respect to x. So if you do that, you're going to end up with what? X. The integral of 1 is just going to be x. Okay. Now what is the integral of minus cosine? Or better enough, forget about the negative and just say, what is the integral of cosine? What can you differentiate to give you cosine? So the derivative of sine is cosine of x. So therefore, the derivative of the integral of cosine of 4x reversing the differentiation is just going to be sine 4x. Now when you're integrating these ones, the trig functions, you are applying u substitution. So when you're integrating, you divide by the derivative of what? Of this part. So the derivative of 4x is 4, so you divide by the 4. If you are differentiating, you multiply by that. Okay, so implying that what we have is minus, maintaining that negative, the integral of that has given us sine 4x over 4. Okay, and then of course plus constant c at the end of the day. Okay, you've got your 1 over 8, which you can decide to distribute. So you have x over 8 minus sine 4x, then 4 by 8 gives us 32 plus c. That's how you handle this first one. We've taken so much time, but I hope you get it. Yeah, what's important is just to practice. Don't get intimidated if you haven't gotten now. With time, everything's going to be at your fingertips. Just a matter of you getting familiar to the questions and the identities. Okay, I'm sure the next ones will actually be, we'll solve them faster. I just wanted to create a solid foundation as we get into it. So feel free to pause the video. The integral of cosine of x minus sine of x squared. What comes to your mind when you see this? So let's try to expand, since I can see it's squared, so that we see what it's going to give us. Cosine times cosine is going to be cosine squared of x. Cosine times that. Remember what that implies is we've got cosine of x minus sine of x coming twice, right? So even in the other bracket we have the same. Okay, so this part multiplied by that or bracket. At the end of the day, you're going to end up with 2 sine of x cosine of x, then plus sine squared of x. Okay, our goal, remember, is to simplify these things, right? So what are some of the things that, what are some of the possible identities that you can create? Now whenever you see this plus that, you know what to do, right? That's a very basic identity. That is one of the first identities you should know. So sine squared of x plus cosine squared of x gives us a 1. So let me write them. Sine squared of x plus cosine squared of x, okay, minus 2 sine of x cosine x. This identity as well, we've dealt with it from the previous part. What comes to your mind when you see that? What identity is coming back to your mind? Okay, pause the video, try to think about it. I hope you have. I'm confident you have. This is a 1 minus 2 sine of x cosine of x. That's just a double angle, right? Sine of 2x. I told you the next one is going to be more easier. And so if you distribute the integral of 1 minus the integral of sine of 2x, remember this is all in respect to the x as well. So your answer will be, for the integral of 1 it becomes x. Integral of sine of 2x is what? Remember the derivative of sine of x is cosine. The integral of sine of x is the opposite, because the derivative of cosine of x, when you differentiate cosine of x, it gives you negative sine of x. Okay? So therefore, the integral of sine of 2x is going to be a negative. I've maintained first of all the negative that is already existing there. Now, the integral of that is going to be negative cosine of 2x. Now, when you're integrating, I said you divide by the derivative of what is attached. Derivative of 2x is a 2 plus a constant c. So that gives us x plus cosine of 2x over 2, right? Plus c. That's for B. That's the answer. Simple and straightforward, right? Okay, you're getting there now. You're getting there. You're building confidence. Now we're on C. The integral of cosine of 2x over cosine squared of x dx. We need to evaluate each of these indefinite integrals. So for this one, is there a way that we can simplify it? If you look at it, this is a square. The top part is a double angle. Okay? So let's try to see what we can do. Let's try to see what we can do. So let's try to expand them. We see. So for the top part, that's going to be, by the way, you should know what that double angle is. So for cosine, it's cosine squared of x minus sine squared of x over the cosine squared of x that we have, right? Okay, cosine squared of x dx. Now our goal is to make sure that we simplify these things as much as we can. So the fact that we're dividing by the cosine squared of x, I would want for us to just have cosine squared of x on top. So we can expand that, we can simplify it. Cosine squared of x minus sine squared of x. You know this is an identity, right? That same identity, the common one of sine squared of x plus cosine squared of x, can be manipulated to get what we want. So if we make sine squared of x a subject, it can become 1. This goes the other side, right? So it will be 1 minus cosine squared of x when you make this a subject. So implying that if you distribute the negative, you're going to have cosine squared of x minus 1 plus cosine squared of x, which just gives you 2 of these minus a 1. Okay, so we can rewrite that. The top part can just reduce to 2 cosine square of x minus a 1 over cosine square of x in respect to x. And we can divide each top part individually by the common denominator. Okay, so split it. 2 cosine square of x divided by cosine square of x, and the other part is 1 over cosine square of x dx. Okay, so we distribute the integral. What do we have? So this would divide. You remain with a constant over 2 minus the integral of 1 over cosine square of x is what? These are some of the other identities that you need to know. 1 over cosine is secant squared of x because it is squared as well. Okay, and all these are being integrated in respect to x. So you and I know that the derivative of tan of x is what? What's the derivative of tan of x? What's the derivative of tan of x? That's secant squared of x. Okay, very important. So if we try to integrate this, the integral of 2 is going to be 2x. The integral of secant squared of x, like I'm from showing you, the implication there is it takes you back to tan of x, of course, plus a constant c. Okay, that's how you handle c. All right, pause. Feel free to pause the video for d. The integral of secant squared of x tan squared of x. A little bit similar to the first one, eh? Yeah, but how do we handle it? This is in respect to dx. Now, this is where you can begin applying the concept of u substitution, which is actually the focus of question 5. So u substitution, think of it in a way that what can you differentiate here, either secant or tan, to match up with the other one? Okay, that's one thing that you need to ask yourself. So I know that if I was to differentiate tan of x, I know it's going to give me secant squared of x. Okay, if I was to differentiate the other guy there, it's going to be probably sec x tan x. Now I want something that will exactly match up the other one. So you've seen this. So we'll let our u be equal to the tan. Let our u be equal to tan of x, and then we'll differentiate it. Du is going to be the derivative of tan of x is secant squared of x. This is in respect to x, so we'll put dx at the end. If we make dx a subject, we have du over secant square of x being equal to dx. Okay, therefore, where we have got secant square of x, we will drop it. Then where we've got tan of x, we said let our u be equal to that, so it's going to be u squared. Then where we've got dx, we're going to have du over secant square of x. Now we can see that this will divide exactly our goal. This will remain u squared du. So basic integration can occur now. What do you do when you're integrating? Increase the power by 1, it will become 3. You divide by the result plus a constant c, which you can now, you know your u was tan of x, so it will be tan cubed of x over 3 plus a constant c. Okay, so that's it. That's how you handle this very basic question. And yeah, we are free now to move on to E. E as well, we have to apply u substitution there. We have sine of x, cosine of x over the square root of 3 plus cosine of 2x. Okay, so whenever you have these ones with radicals, always try to attempt to use u substitution to be equivalent to whatever is under the radical. So we have 3 plus cosine of 2x. Let's attempt to differentiate. We see what it's going to give us. So our du becomes, the constant of course will just cancel out. What's the derivative of cosine? It's negative of sine. Negative sine of 2x. Now when you're differentiating, I said you multiply by the derivative of whatever is attached to the trig function. So multiply by 2, which will eventually give us a minus 2 sine of 2x in respect to x dx. Okay, so that's what we've ended up with there. Okay, now if you look at it, this is a double angle. Remember, our goal is we want to like somehow do away with what is on top there. So if we try to expand it, it may be of some help because that looks like something similar to this double angle. So that gives us, if you expand this, by now you should know that that's 2 sine of x cosine of x. Okay, so therefore we have negative 4 sine of x cosine of x dx. So if you make the x the subject of a formula, you divide both sides by negative 4 sine of x cosine of x, you're going to end up with sine of x cosine of x over the square root of 3 plus cosine 2x. I'm just dropping that. Now this part we'll put du over negative 4 sine of x cosine of x. Remember what is under the square root there, we said it's going to be equal to u, right? From there. So we can see now that these can divide. That's 1 there. There will remain with a negative 4. Okay. So what remains is 1 over, we've got negative 4 on the bottom attached to the square root of u. So that is exactly what we need to integrate. You and I know that at this stage where we've got the right or the privilege to pull out the negative 1 over 4. Okay, so that we just integrate 1 over the root of u. Now that guy as well, I believe we should know that negative 1 over 4, 1 over u, or 1 over root of u is the same as 1 u to the power half, which we can make to be negative 1 over 4. Again, it can go to the top part so that it becomes to negative half. That will be u to the power negative 1 over 2. So to integrate, what do you do? Add the 1, divide by the result. So 1 over the result, of course it's 3 over 2. Okay, so therefore answer becomes, my space. So maintain the negative 1 over 4, multiply by u will become the power 3 over 2. Dividing by 3 over 2 is as good as multiplying by the reciprocal, 2 over 3. So we have negative 2 over 12 when we multiply 4 and 3, and then u to the power 3 over 2 plus constant c. So the 2 can divide there, so that you have negative 1 over 6 u to the power 3 over 2. Now our u can bring back what is due. U is equivalent to 3 plus cosine of 2x raised to the power, let me write that properly, cosine of 2x raised to the power 3 over 2 plus constant c. That is our integral for that interesting question, which is E, right? Yeah. So that is our final answer. Okay. So that is if all our operations that we've done were good enough. No, I've messed up somewhere. I've messed up. Negative half plus 1 is negative 0 is equal to 0 over 2. No. So whatever you get as a result there, you need to divide by it as well, which is of course going to be negative half plus 1. 1 minus half is just half, right? And plus constant c. So our final answer will be negative 1 over 4. Dividing by half is as good as multiplying by a reciprocal, which is 2 over 1. Then u to the power negative half plus 1 is just going to be u to the power positive half plus constant c. So this will be 2 over 2, so negative 1 over 2. Our u is 3 plus cosine of 2x raised to the power that should be the power 1 over 2 plus c. Now that 1 over 2 is as good as just bringing back the square root. Okay, so that's the answer that I've ended up with after the manipulations that we've done. Okay, we can move to f now. So for f, what we have is the integral of cosine 3x plus sine of x, then divided by cosine squared of x dx. Okay, so I think this one is just go on. This is a common denominator. We can just go on and try to divide. So cosine cubed of x divided by cosine squared of x plus sine of x divided again by the same cosine squared of x. We can break it down. Cosine of x times cosine of x. Okay, we can decide to put a 1 there, dx. Okay, so this is going to be very basic. We've got 3 of cosines on top divided by 2 of them, so 1 will remain on top, cosine of x, and then plus this guy. Sine over cosine is tan of x. 1 over cosine is what? Secant of x. So that's a product of it too. So in the brackets to imply that the integral applies to everything. Okay. Now I was trying to ask you earlier to say, you know that the derivative of tan, is what? Secant square of x. How about the derivative of secant of x is what? What's the derivative of secant of x? It's secant of x tan of x. Okay, so is it possible that we can actually integrate directly at the point where we've reached? Yes, very possible. So the integral of cosine of x is known, so is the integral of tan fact, let me even start with secant of x, tan of x. This is also known. So the integral of cosine is what? Because the derivative of sine is cosine, so this is going to be sine of x plus this is going to give you what? Secant of x. Because the derivative of secant of x is that, plus constant c. That's how simple you can do away with f. Then we can now consider g. For g, the integral of 1 plus sine of x, and then we have squared there. Let's expand it. We remain with 1 times 1, that's going to be 1 times sine x, that's going to be, so that's going to be plus 2 sine of x when it comes twice, plus sine squared of x. That's what we get after we do the expansions there. Now I told you where it is necessary for you to substitute is where you've got the squared. Okay, you bring in the half angles, right? I mentioned that. So we'll maintain the first part. We have 1 plus 2 sine of x, which we can actually integrate normally. And yeah. Now for that part, where we have sine squared of x, I said it's the same as what? So I said sine squared of 2x, in fact, of theta, or of x. So this is the same as 1 minus cosine of 2x over 2. So yeah, and depending on how you want to write it, this can be, you can pull out the 2 on the bottom so that it becomes 1 over 2, and then you remain with 1 minus cosine of 2x. So we can pull out it that way so that we have 1 over 2, and then in the brackets we remain with the 1 over, or the 1 minus cosine of 2x. Okay, like that. This is supposed to be integrated in respect to x. Okay, and so we can try to simplify this a little bit. You're going to have 1 plus 2 sine of x. Distribute the half, you're going to have 1 over 2 minus 1 over 2 cosine of 2x, of course with dx at the end. Now it appears we've got some like terms, half and 1, without even wasting time. And 1 can be added to the half to give us 3 over 2. Okay, that's one thing that I'm confident of. Okay, and we can try now to integrate this, each piece. Okay, so the integral of 2 sine of x is what? This guy. So when you're integrating sine, it's the opposite of the differentiation. Derivative of sine is cosine. Now the integral of sine again is also going to be cosine, except the sign is different, so it's negative cosine. In fact, there's a 2 in front, right? So negative 2 cosine of x. Now when you are integrating, you need to divide by the derivative of what is attached. So it's just x. Dividing by 1 will not give us any difference. The integral of 3 over 2 is 3 over 2x. Whenever you're integrating a constant, just introduce a variable. Then this part, 1/2 cosine 2x. Similarly, what's the integral of cosine? It's sine. Sine what? Sine of 2x. Now you divide by the derivative of 2x, which is 2. Okay, plus constant c at the end. So therefore our final answer is what? So I can decide to start with the 3 over 2. 3 over 2x minus 2 cosine of x. 2 times 2 is 4, so minus 1 over 4 sine of 2x plus constant c. That's how you handle your g right there. Now we're finally on the last one for question 4. It's been a journey. I hope you've learned a lot. So for h, something deeply, heavily based on the identities. Determine the integral of sine of 3x cosine 3x dx. I'll introduce you to an identity which creates this relationship. Whenever you have sine of, let's say, alpha and then cosine alpha, okay, this should just be equal to half sine. You're going to double the alpha. Okay, that's this. Remember where this is coming from, right? Even when we said for sine theta, or sine x cosine of x, it was giving us half sine of what? 2x. Okay, so this is where you can remember this is from. Now when you've got 3x there, what happens? So sine, if you substitute 3x, it becomes 1 over 2 sine of, where there is 2 to be doubled. Okay, so it becomes 6x. So that is the same as the integral of 1 over 2 sine 6x, which is simple and straightforward for us. And we can pull out the constant 1 over 2, so that we remain with the integral of sine 6x, of course in respect to x. So what is the integral of sine? That's negative sine. I'm talking about that negative cosine of what? 6x. I said, what do you divide with? Divide by the derivative of whatever is attached to it, which is a 6 plus constant c. Okay, now this becomes negative 1 over 12 cosine of 6x plus constant c. Yeah, that's it to h, and we're done with the entire question 4. Let's move to question 5. So just before we jump into question 5, some of you have been struggling. In fact, most of you probably have been struggling with the identities I've been using in this video. So you'd want to head over to the site using the link in the description below to learn the identities. Very brief videos ranging from the half angle formulas, the double angle formulas, the basic normal identities. You get to know them all. Yeah. Hi. So I just wanted to let you know that all these questions, all the way from 1 up to question 11, are all answered. Okay, from the area concepts, different kind of integrals, partial fractions, by parts, use substitution, trigonometric functions are all handled in this video. And of course, if you want to learn the other concepts of calculus, they're available on our site. The link is in the description below. You'll be able to learn everything from scratch, and of course have the direct solutions to this tutorial sheet in full. Okay, thanks very much for watching, and have a lovely day.